Friction and resistance. Friction and resistance are forces that oppose the motion of objects. Understanding these concepts helps explain why objects slow down, stop, or require more force to move. Let's dive into the details of friction, air resistance, and water resistance. Friction is a force that opposes the motion of one object moving past another. It acts in the opposite direction of the motion. How friction works. When two surfaces come into contact, the microscopic irregularities or bumps and grooves on each surface catch on each other, creating friction. Friction always acts in the direction opposite to the motion of the object. Friction allows the tires on a bike to grip the road surface. Without the grip, you couldn't make the bike move forward, and you wouldn't be able to stop it either. It would be like riding on ice. Friction also acts at the brakes, where they rub on the rim of the wheel or on the brake disc. Friction always wastes energy. Friction between the moving parts of a bike warms up the gear and bearings. It is wasted energy. Friction limits top speed as well. At high speed, air resistance takes up most of your energy and limits your maximum speed. Over time, friction can cause surfaces to wear down. Air resistance is a type of friction that occurs when an object moves through air. It opposes the motion and increases with the object's speed. How air resistance works. The larger the surface area facing the direction of motion, the greater the air resistance. As the speed of an object increases, air resistance increases. Streamlined shapes reduce air resistance, e.g. the shape of a car or airplane. Objects moving through air, like a falling parachute, slow down due to air resistance. When the force of air resistance equals the force of gravity, an object reaches a constant speed called terminal velocity. Water resistance is like air resistance, but occurs when an object moves through water. It also opposes motion and increases with the object's speed. How water resistance works. Water is denser than air, so water resistance is generally stronger than air resistance. The faster an object moves through water, the greater the resistance. Streamlined shapes help reduce water resistance, e.g. the shape of a fish or a submarine. Objects like boats or swimmers experience resistance that slows them down. More energy is needed to move through water than through air due to higher resistance. Understanding these forces helps explain everyday phenomena and is crucial in designing efficient transportation, sports equipment, and machinery.